The rules that we discussed on the previous page also exist on this page, specifically the product property of exponents and the quotient property of exponents, as well as the power of a power. One property that we'll talk about real quick on this page is the zero exponents property. Basically, it says any number to the zero power equals 1. Here's why. 2 to the first power means 2. 2 squared means 2 times 2, which is 4. Cubed means 2 times 2 times 2, which is 8. And essentially the pattern moving upward is to double every time. So we have 2, 4, 8, 16, 32, 64. If we work in reverse and go down, the pattern is reversed. So in this instance, we'd be dividing by 2 every time. Same ratio that we go up by. So 64 divided by 2 is 32. 32 divided by 2 is 16. Divided by 2 is 8. Divided by 2 is 4. Divided by 2 is 2. 2 divided by 2 is 1. And then 1 divided by 2 is 1/2. 1/2 divided by 2 is 1/4. 1/4 divided by 2 is 1/8. What you may notice is the denominator in the lower section is the same as 2 to the third in the upper section, or 4 is the same as 2 squared. -1 is the same as 2 to the first. So when you have a negative exponent, that's another rule. You basically move that exponent and make it positive. So if it starts in the numerator, you move it to the denominator and make it positive. If it starts in the denominator, you move it to the numerator and make it positive. So let's look at a couple of examples because that does not make any sense. A few basic ones to start with. Exercising our first rule, where if we're multiplying the same base, we add the exponents. Here we have 7 and 4. This becomes x to the 11th power. Another property we just talked about is that if you have 2 of the same base being divided, you take the numerator's power minus the denominator, so 7 minus 4. And the third example here is when we have powers stacked, as I call it. If you have a power raised to another power, you're going to multiply those. So we would have x to the 28th. On this page, we have a little bit more complex. We have some numbers as well as variables. If we look at 15 and 21, both of those have a common divisor. And the greatest common factor for both of them, or the greatest number they can be divided by, is 3. 15 divided by 3 is 5. 21 divided by 3 is 7. Now, normally what I'll do is ask my students, where do we have more x's? So in the numerator, there's x to the third power, which means there's 3 of them if they're written out. In the denominator, we have 6 of them if you write it out. So that means that in the denominator, we have more, and we actually have 3 more than the top, because 6 is 3 bigger than 3. So this reduces to 5/7, x to the third. If you use the rule, you would have 3 minus 6, which is -3. So you'd have x to the -3. And our rule says if it's a negative exponent, you move it to the denominator. The next example has a coefficient and it has an exponent. If there's an exponent and multiple terms on the inside, you need to distribute that exponent, essentially. So what we'd have is the 3 would remain, and we'd have 4 squared, and then x cubed raised to the second power. So in that instance, we would need to multiply the exponents because they are stacked. So what we have is 3 times 4 squared is 16, x to the 6th. And then we can multiply, and we get 48 x to the 6th. Our last example, before I do anything with the numbers, I see a negative exponent right here. So what I would do is I would just rewrite that in the numerator. Again, if the power is negative, or if the exponent's negative, move it and make it positive. So we would have 12x cubed and then x to the positive side. Sorry again. And then we'd have 18 on the bottom. The numbers would reduce. So 12 and 18 are both divisible by 6. So we'd have 2 and 3. Because 12 divided by 6 is 2, 18 divided by 6 is 3. And then we have 2 of the same base being multiplied, so we're going to add the exponents. And then the last 2 examples are one with a negative exponent on the outside of a fraction. So what we would do in this case is distribute that power again to both pieces, and we'd have 3 to the negative 2 over 5 to the negative 2. And because they're negative exponents, to deal with that, what we do is move it and make it positive. So it would become 5 to the positive 2 in the numerator, and 3 to the positive 2 or squared in the denominator. So we would get 25 over 9. Again, this moves because the power was negative. Pretty simple. If the exponent is negative, move it and make it positive. And our last example is just a bunch of variables. So this first part, we have some x's in the numerator and in the denominator. Where do we have more? That would be in the top. And 3 is 3 bigger than 0. So we have 3 more in the top. Then we've got y's in both the numerator and denominator. And we have to ask ourselves, where do we have more? The answer to that is in the denominator, because there are 4 in the denominator and only 1 in the numerator. So this is bigger by 3, so it's going to be y cubed. Now you guys have an assignment. It's on 5.2 worksheet. I want you to do the top section, the middle column on the bottom, as well as number 13 and 16.